Powers of monomials. The objective of this lesson is to find powers of monomials. Okay, let's take a look at this example. Recall that when you multiply powers that have the same base, you add the exponents. Like this example, 3 squared times 3 cubed equals 3 raised to the 2 plus 3, or 3 to the 5th power. But how do you find the power like 3 squared raised to the 3rd power? Okay, you can use a calculator to discover this pattern for one. Okay, and let's see how this works. You have this table. Okay, you can copy this table in your notebook and use the calculator to find each value and complete the table. Now you can pause this and find the value with your calculator and then just play it again after you do that. Okay, so if you enter 3 squared in your calculator, obviously you'll get answer 9. Okay, 3 cubed would be 27. Okay, 3 to the 4th power 81, 3 to the 5th power 243, and 3 to the 6th power would be 729. Okay, using your calculator. Okay, let's take a look at this. This column right here, and you have 3 squared raised to the 1st power, that is equal to 1. Okay, 3 squared raised to the 2nd power, that will be 81. 3 squared raised to the 3rd power, 729. 3 squared raised to the 4th power, 6,561. 3 squared raised to the 5th power is 59,049, and 3 squared raised to the 6th power is 531,441. Take a look at those numbers and look at 3 to the 4th power and 3 squared raised to the 2nd power. They are both 81. And in the same manner, 3 to the 6th power, okay, is the same as 3 squared raised to the 3rd power. Okay, think about the relationship of those two powers. Okay, so what do you observe? So you probably observe that if you look at 3 to the 2nd power raised to the 2nd power, or 3 squared raised to the 2nd power, it is the same as 81. And if you look at the exponents, okay, if you multiply 2 times 2, that becomes 4 right here. So if you get 2 times 2, okay, you end up with 4, which is the same as 81. In the same manner, if you look at 729, if you multiply 2 times 3, you get 6, which is the same as 729 in this area. Okay? That's basically the pattern behind that table. So if you look at letter C, guess the value of 3 to the 4th power raised to the 2nd power. Okay? This will be, what do you think? Okay? This will be this number right here. Why? Because this is the same as, if I multiply that, this is the same as 3 to the 8th power. Okay? Let me write that again so that it won't disappear. So this is the same as 3 to the 8th power. Okay? And if you notice, 4 times 2 right here will also be 3 to the 8th power. Okay? Your answer for this one would be 6,561. Okay? So now we found the pattern. Let's move on. Let's consider the following powers in this case. You have 5 to the 4th power. Okay? Raised to the 2nd power. This is basically the same as 5 to the 4th times 5 to the 4th. Okay? And if you notice, this is multiplying exponents. When you multiply two exponents with the same base, all you need to do is add the exponents. That's why you have 5 raised to the 4 plus 4, which became 5 to the 8th power. Now let's take a look at the other side. Okay, when you have x to the second power raised to the third power, you are using x squared as a factor 3 times, just like you use 5 to the fourth power as a factor 2 times. So this becomes x squared times x squared times x squared. Then going back to the rule of multiplication of exponents, okay, when you add the exponents, 2 plus 2 plus 2 becomes x to the 6th power. Okay, these and other similar examples suggest that you can find a power of a power by multiplying exponents. Okay, which brings us to this rule. So for any number a and positive integers m and n, a to the m raised to the nth power is a to the mn. Okay, that is a rule. So basically what you do is multiply the the exponents m and n, okay, and then leave the base the same. Let's take a look at example number 1. Asks us to simplify p to the 6th power raised to the 2nd power. Okay, again, following the rule, we multiply 6 times 2, and then we end up with p to the 12th power. If we check our answer, if you notice, if we use p to the 6th as a factor twice, p to the 6th times p to the 6th, using multiplication of the rule of multiplication of exponents, you now have p to the 6 raised to the 6 plus 6, or p to the 12. So our answer checks out. Okay? How about this one? The volume of a cube can be found by multiplying its length, width, and height. Remember the formula for volume of a cube. Volume of a cube is nothing more than, okay, volume is equal to big B times h, where big B represents the area of your base. In this case, the area of our base is a rectangle, and that's the reason why we multiply the length and the width, and then we simply multiply it with the height. Okay, that was just a little bit of a review. The volume of a small cube shown at the right, okay, is x times x times x, or x cubed. If the length of each edge of the cube is doubled, the volume of the new cube would be 2x cubed. Okay, and that is the same way, and that's this is your big cube and this is your small cube. Okay, since the cube has all sides congruent, okay, the volume is actually, we can expect the volume formula to become s cubed, where s represents the side of a cube. And that's why you have s to the 3rd power and x cubed. Okay, so let's say you have 2x raised to the 3rd power. Okay, if we use the definition of exponent, or in our case, the rule of multiplication of exponent, we now have 2x times 2x times 2x, okay? And then using the commutative and associative properties of multiplication, okay? We move all the 2's next to each other. We move all the x's next to each other. We have 2 times 2 times 2, x times x times x. We end up with 2 cubed, x cubed, okay? And then after that, we simply simplify 2 to the 3rd power, which is 8, okay? Not 6. 2 to the 3rd power is 8, x cubed, okay? And that is now the volume of our bigger cube, 8x cubed, okay? Notice that when 2x was raised to the 3rd power, both the 2 and the x were raised to the 3rd power as well. This example suggests that the power of a product can be found by multiplying the individual powers. What does that mean? It simply means this, that we bring up another rule, power of a product, for all numbers a, b, and positive integer m. ab raised to the m power is equal to a to the m, b to the m. Okay, just like what we did in 2x cubed, what we did was that if you have 2x raised to the 3rd power, this becomes now 2 cubed and x cubed. Okay, and this is what we got right here, 2 cubed x cubed. Okay, Let's see how this works. Example number 2, the formula for volume of a pyramid is equal to 1/3 length, width, and height. Okay, find the measure of the volume of the pyramid. Again, going back to our formulas, why is this 1/3 length, width, length times width times height? Because the volume of a pyramid, if you recall, is equal to 1/3 times base times height, where capital B represents the area of the base. Okay, this represents the area of the base, and in our case, the area of a base is a square. Okay, so this can actually, and that's the reason why you have length times width. Since the length and width are the same, you can multiply 4x times 4x. Okay, anyway, going back to our problem, find the measure of the volume of the pyramid using that formula. So we write the formula. Volume equals 1/3 length times width times height. Substitute the values of length, width, and height. Okay, then they're all 4x. Length, width, and height are all has a measure. All have measures of 4x. Okay, using the commutative and associative properties, put all the 4's together, put all the x's together. You now have 1/3 times 4 cubed x cubed. Simplifying it further, use exponents first. Okay, now I have 1/3 raised to the 4x cubed. Okay, I'm sorry, that's 1/3 multiplied by quantity 4x raised to the third power. And this is the rule that we just talked about, power of a product. Okay, so the volume of our cube now will be 1/3 times 4x raised to the third power. Okay, let's move on. Sometimes the rules for the power of a power and a power of a product are combined into one rule, another rule. Okay, so we expand our rule further. Now have a power of a monomial for all numbers a and b, positive integer m, n, and p. If you have a to the m, b to the n, all of that raised to the p power, it equals m a to the mp, b to the mp. Basically, you're multiplying the exponent m times p and m times p for if you have a base of a and a base of b. Let's take a look how this works in this example. Let's simplify x squared y cubed y to the fourth. Okay, following this rule, we need to multiply 2 times 4. Okay, we need to multiply 2 times 4, and then we need to multiply 3 times 4. Okay, so this is how it works. You now have x squared y to the fourth, x squared raised to the fourth, y cubed raised to the fourth. Again, power of a monomial, the last rule that we had. So we simply multiply those two exponents, 2 times 4, 3 times 4, end up x to the 8th, y to the 8th power. Okay, and let's check our answer. If we use x squared y cubed, okay, as a factor 4 times, this is what comes out. 1, 2, 3, 4, 4 times. We use the commutative properties and associative properties, okay, for this. We now have x squared, x squared, x squared, x squared, multiply them all together. Same thing with the y cubed. Now have multiplication of exponents, where you add the exponents when you're multiplying exponents, when you're multiplying powers. So you now have 2 plus 2 plus 2 plus 2. Same thing with the y, 3 plus 3 plus 3 plus 3. It becomes x to the 8th, y to the 12th. Our answer checks out. Okay, so that's another rule. That's a third rule for this lesson, power of a monomial. Okay, let's take a look at this example. These rules can also be used with negative exponents using the same rules. Let's say you have x cubed y squared z, all of them raised to the negative 2. So what do? We copy the problem first, and the first thing we do is, okay, we use the power of a monomial. So this becomes x cubed y times x cubed multiplied to the by negative 2. y squared multiplied by negative 2, y to the first multiplied by negative 2. Remember, if a variable does not have an exponent, okay, it is raised to the first power. So what did we do? We simply, okay, distributed negative 2 to all three powers. Okay, and this is what we got. From there, okay, we multiply 3 times negative 2, so this becomes x to the negative 6. We multiply 2 times negative 2, y to the negative 4. We multiply 1 times negative 2, y z to the negative 2. And let's check our answer. Remember that one of the rules that we learned also in the past is that if you have a to the negative n, this is the same as 1 over a to the n power. And that's the reason why when you have x cubed y squared z raised to the negative 2, it is the same as 1 over quantity x cubed y squared z raised to the second power, following this rule right here. Okay? So from there, we use x cubed y squared z as a factor 2 times, and then we multiply them next with each other. Using commutative and associative properties, put all the x's together, put all the y's together, and put all the z's together, add their exponents. Okay, we have now 1 over x to the 6, y to the 4th, z squared. Okay, and our answer checks out: x to the negative 6, y to the negative 4, and z to the negative 2. Okay, this is actually another way. Okay, this is actually another way of solving this particular problem if you do not remember the rule. Okay, if you just remember our basic rules that we learned in the beginning, this is another way of solving this. And that's it. So basically make a summary of what you've learned today, put it on Google Forms, write a question that you might want to ask in class. Thank you.